Good morning, everyone. Today, our group will be presenting on Rotary Variable Differential Transformer, or RVDT. We'll explore its definition, how it works, its internal structure, real-life applications, its advantages and limitations, and how different it is from LVDT. Let's begin with the basics. A Rotary Variable Differential Transformer, or RVDT, is an inductive transducer that converts angular displacement into a proportional electrical output signal. It operates using the principle of mutual induction, similar to an LVDT, but instead of linear motion, it measures rotational motion. The main function of an RVDT is to measure the amount and direction of angular rotation. It converts mechanical rotation into an electrical AC signal, which can be used for monitoring, control, or feedback in control systems. Some key characteristics of an RVDT include: it measures rotary displacement, operates with AC excitation, and produces a differential AC output. The output is linear within a limited angular range, usually between plus or minus 30 to 60 degrees. It is also a non-contact device, which increases its durability and lifespan. Now, let's look at what is inside an RVDT and how does it operate. An RVDT consists of four main components. First, the primary winding, which is supplied with AC voltage. Second, two secondary windings, which are connected in series opposition. Third, a rotating ferromagnetic core, also known as the rotor. Finally, a shaft, which is connected to the rotating object whose angle is being measured. But then, how does it work? RVDT works based on the transformer principle, specifically mutual induction. When an AC voltage is applied to the primary winding, an alternating magnetic flux is produced. As the rotor rotates, the magnetic flux linking each secondary winding changes. This causes different voltages to be induced in the two secondary windings. The output voltage would be the difference between the two secondary coil voltages. Vout equals to Vs1 minus Vs2. There are also three different cases during an RVDT operation. In case 1, when the rotor is at the null or central position, both secondary windings receive equal flux. Therefore, the induced voltages are equal, and the output voltage is 0. In case 2, when the rotor rotates clockwise, the output voltage becomes positive, and in case 3, when it rotates counterclockwise, the output voltage becomes negative. Hence, the magnitude of the output represents the angle, and the polarity represents the direction. Now that we know how it works, what is so special about RVDT? RVDT offers several advantages. It provides high accuracy and repeatability, has no physical contact, which reduces wear and tear, offers long operational life, and performs well in harsh environments. However, RVDT also has some limitations. It has a limited angular range, requires AC excitation and signal conditioning to operate, and is generally more expensive than simple sensors like potentiometers. Its output is also in AC, which needs demodulation. Now, we look at how different RVDT is to its counterpart, Linear Variable Differential Transformer, or LVDT. Firstly, RVDT measures angular displacement, while LVDT measures linear displacement, since the core in RVDT rotates inside the transformer, while the core in LVDT moves linearly along the transformer's axis. Secondly, both gives out AC voltage output signal, but in RVDT, the voltage is proportional to the angle of rotation, while in LVDT, the voltage is proportional to the linear displacement of the core. Thirdly, the construction of both are different, with RVDT being a cylindrical stator with primary and secondary coil around it, while LVDT has a hollow cylindrical coil and two secondaries. Lastly, for their signal conditioning, RVDT needs a converter to interpret the phase shift, while LVDT signal can be processed with simple differential amplifiers. Now that we know the basics of an RVDT, where can we use it? RVDTs are widely used in applications that require precise angular measurement, Examples include in aerospace, for cockpit control positions and adjusting wing flaps. Precise robotic joints and limb movements in robotics. Automation processes, CNC machinery, and valve position monitoring in industrial works. And in medical work for X-ray monitoring and surgical robots. In conclusion, RVDT is an inductive transducer used to measure angular displacement accurately. It works on the principle of mutual induction and provides a reliable, non-contact method of angle measurement. Due to its accuracy and durability, RVDT is widely used in many sectors, especially in aerospace, robotics, and control systems. We hope that this video has given you an insight into RVDT, its incredible mechanism, and how useful it is in our lives. Thank you for watching. Don't forget to like and subscribe, and have a good day.